Hello friends, we had started learning of statistical concepts as a part of measure phase from last video. So far, we had seen need of statistics and measures of central tendency with practical examples. Before starting the concept of measures of dispersion, let's understand some basic concepts which are required to understand this. So let's begin. Population, sample and sample size. Whenever we hear the term population, the first thing that strikes our mind is a large group of people. In the same way, in statistics, population denotes a large group consisting of elements having at least one common feature. Making it simpler, we can say population is an entire set of atoms. Whereas, sample is nothing but the part of population that is so selected to represent the entire group. I think this makes clear about the concept of population and sample. Now, to make the judgment about population from sample, we have to take some number of samples in consideration. This number of samples is called as sample size. Do you have an idea how this works? Let's see. To make a judgment about population, we select some samples from it and we measure it based on its characteristics. If it is meeting acceptance criteria, then we use the entire lot for processing. But if it is failed to meet acceptance criteria, then we have to take actions accordingly, that is, reject or rework. This has to be closed loop by taking corrective actions and preventive actions for single incidence and validating its effectiveness. In case if it is repetitive, this is an area where we can initiate DMAC projects. Sampling methods and their use. There are 4 types of sampling methods used to collect samples. 1. Simple random sampling. In this method of sampling, each individual is chosen entirely by chance and each member of the population has an equal chance of being selected. 2. Stratified random sampling. In this method, the population is first divided into subgroups, also called as strata, who all share a similar characteristic. It is used when we might reasonably expect the measurement of interest to vary between the different subgroups. 3. Systematic sampling. In this method of sampling, individuals are selected at regular intervals from a list of whole population. The intervals are chosen to ensure an adequate sample size. For example, every 10th member of the population is included in the sampling. And 4. Sampling subgroups. In this sampling method, the data is collected for n units for each x unit of time. Let's say 3 units for each full minute in every 30 minutes. And then calculate the mean of each subgroup. Sampling must be representative. This is the most important thing during sampling. It must be representative to enable true and valid conclusions. Here, representative means 1. The data have to represent population, and 2. There should be no systematic difference between the data we collect or we do not collect. Some sample size standards for charts in statistics. Here is a recommended sample size to draw charts in statistics for better conclusions from them. For frequency plot and parameter chart, it should be 50, and for scatter plot and control chart, it should be 24. We can draw these charts with lesser number of sample size too, but the mentioned sample size will give us the more accurate results. After understanding of these concepts, let's move to the measure of dispersion. Before going to measures of dispersion, you must know what is variation and normal cause as well as special cause variation. If you knew it, then let's go to the next concept. If you don't, I had already explained these concepts in control chart. You can learn it just by clicking on this card. Measures of dispersion. The extent of spread of the values from the mean value is called as dispersion. The measures of dispersion are 1. Range, 2. Variance, 3. Standard deviation, and 4. Coefficient of variation. Standard deviation is the most commonly used measure of dispersion. 1. Range, denoted by R. It is defined as a difference between highest and lowest observed values. That is, range is equal to value of highest observation minus value of lowest observation. For example, let's calculate the range for this data. Range is equal to 12 minus 3, which is equal to 9. 2. Variance. It is denoted by S square. It is a measure to compute the distance of any observation in the dataset from the mean of the distribution. Population variance is commonly referred by sigma square, while sample variance is expressed by S square. Here, S square is equal to summation goes from I is equal to 1 to n xi minus x bar bracket square divided by n minus 1. Here, S square is the variance, n is the number of data points, xi means individual values of the data, x bar is the average of the data points. The reason for dividing by n minus 1 instead of n, there are only n minus 1 independent deviations, that is xi minus x bar. 3. Standard deviation, denoted by S. To bring the variance in the same unit as the data under observation, we need to compute the square root. This is called as standard deviation. Sample standard deviation is commonly expressed by S, and it is positive square root of the sample variance. That is, S is equal to square root of S square. Let's continue with the same example to calculate variance and standard deviation. Let's calculate these measures manually first and then in Excel and in Minitab. In this example, mean is equal to 6.67 and variance is equal to sum of squares of difference between each data point and mean value and then divided by n minus 1, which is equal to 7.5. This is time consuming activity. Instead of calculating these values manually, I am recommending you to please use Excel, Minitab or other statistical softwares. To calculate variance in Excel, simply use a function VAR. Let's do it for the above example. Use the function is equal to VAR 𝘁𝗿𝗍𝗁6, which is equal to 7.5 as per the diagram. Similarly, we can calculate standard deviation in Excel. There are two ways to calculate the standard deviation. One, use function SQRT if variance is known to us. That is, standard deviation is equal to SQRT E8 in our example, which is equal to 2.7386. And second, simply use a function of STDEV. Standard deviation is equal to STDEV 𝘁𝗿𝗍𝗁6, which is equal to 2.7386. 4. Coefficient of variation, denoted by CV. The coefficient of variation is the ratio of standard deviation to the mean. The coefficient of variation is useful because the standard deviation of the data must always be understood in context the mean of the data. In contrast, the actual value of CV is independent of the unit in which the measurement has been taken, so it is a dimensionless number. In the above example, CV is equal to standard deviation divided by mean into 100, which is equal to 2.7386 divided by 6.67 into 100, which is equal to 41.08%. The higher the coefficient of variation, the greater the level of dispersion around the mean. It is generally expressed as a percentage. The lower the value of coefficient of variation, the more precise the estimate. The simplest way to get all these measures instantly is a display descriptive statistics option in the Minitab. Let's see how to do it. Firstly, enter the data in Minitab worksheet as shown in the picture. If you have already data in Excel, copy from there and paste in the Minitab worksheet. Then go to Stat menu, select Basic Statistics and then select Display Descriptive Statistics. This option summarizes our data and displays the result in session window. After selecting this option, new window will be open, same as that of the picture. Select our data column C1 in Variables and click on Statistics tab for selecting options we want to see about our data. Then click OK. The window will be open same as that of the picture. In this window, select what measures we want to know about our data. For example, mean, standard deviation are always default, but as we also want to know variance and coefficient of variation, so I have checked these boxes additionally. After selecting terms which we want to see, click OK. And then here is a detailed statistics of the data we want to know about it. Mean is 6.667, median is 6, standard deviation is 2.739, variance is 7.5 and coefficient of variation is 41%. Minimum data point is 3 and maximum data point is 12. This is all about sampling and measures of dispersion. We will see some more important concepts in next videos before to start learning of tools in the measure phase. Now to end, share this video on your entire group to improve their life at professional level. Add your valuable comments and suggestions regarding it. I will be sharing such an important concepts in Lean and Six Sigma usually once in 2 weeks. If you don't want to miss such useful information on my channel, then click on the bell icon after subscription and select an option of Get All Notifications. And finally, thank you for watching.